Remember from when we defined them that the most important property of a statement is it can be one of two things. Either a statement is true or a statement is false. So, often when we're talking about statements in more of a real context than just music lyrics, we care most about whether or not that's the case. That is, we care about the veracity of a statement, the truth of it, or the falsity of it, depending on what we're looking at. So, for some very basic examples here in more of a mathematical sense, if I have a statement like P is that 7 is greater than 6, along with Q is that 5 is less than 6, hopefully it's pretty easy to tell that both of these statements are true, which would mean that if we took their negations, we looked at not P and not Q, we would get false statements. Statements of form 7 is less than or equal to 6, and 5 is greater than or equal to 6. Because remember, if you negate something, if you take the opposite of a less than, you get both greater than and equal to. You have to get all the things in there when you're taking it. And then from there, if we want to talk about stuff with conjunctions and disjunctions, if we took something like not P or Q, that is, we took the disjunction of P being negated, along with Q being left alone, we get something that in that case is true because Q is true. While if we took something like not P and Q, the conjunction, we would get a statement that's false because if we have one thing that's false, then both of them can't be true. They have to both be true in order for it to be true. And hopefully, looking at these connections, looking at how these connective things start to work, gives us some sense of, well, that this gets a little complicated. That even with just two statements, it can be a little bit hard to track when something is true, when something is false, and actually understand what's going on in totality in terms of our various options. Because when you have two statements, P and Q, and we're trying to find out how they can be brought together and when different parts of it are true, you've got 4 different options, and it might not always be obvious. And then from there, if you take more things, you get more options than that. You actually get 2 times your total options for every new statement added in. That's, again, a hint towards the fundamental counting principle that we'll see in practice a bit more here. But the point is, it's complex to think of just in terms of words and in terms of these condensed notations. So it might be good to have something that gives us a little bit more of a compact notation for describing all of the cases we can have for things of this nature. And that is where we get to a design put together by C.S. Peirce in the late 19th century that's been used since, called a truth table. Where what a truth table does is it takes all of the information in terms of our statements and condenses it down to the options for whether the thing is true and whether the thing is false. And if you want to think about that for something very simple, like a negation of a statement, remember that it can either be true or false. So we have P is true or P is false. And then if we negate it, we flip whether it's true or false. So not P is false when P is true, and true when P is false. And then from there, we can take this into more and more complicated cases with 2 different things at once, where we're going to look at the simpler versions with conjunctions and disjunctions for now. We're going to get more complex as we're going through here, and then in the next section, we'll see what happens with more conditional things, because those are a little more subtle. But if we want to deal with either a conjunction or a disjunction, we have to understand that we get 4 options with 2 simple statements. Either they are both true, they are both false, one is false and the other is true, or the reverse of that third arrangement. Where if we want to talk about these things, we can take all 4 of our options, where for P, we can say that P is true and Q is true, or P is true and Q is false, P is false and Q is true, and both are false, where in the case of a conjunction in particular, we would have that the conjunction P and Q is only true when both are true, because in order for both to be true, both need to be true. That's sort of a tautology, but we'll get to that later. And resultingly, if either is false, or even if both are false, the whole thing has to be false. And then if we go from there to think of things in terms of disjunctions, it has the same sort of flavor, but before we get to that, I just want to refocus down here on exactly what it is that we're doing. Where for one, the pattern we usually follow here is in terms of powers of 2, that we can sort of think of the first one as being all the trues, then all the falses, then it alternates a little bit more, but we'll see more about that as we go past just 2 simple statements, where for a conjunction, we're thinking about the resulting truth of an and flavored statement. So if we give a specific case here, we say that P is the statement penguins can fly, while Q is the statement penguins can swim. The conjunction there, penguins can fly and penguins can swim, would be false because we have that P is false. It would fall into that third case there for being true or false because, well, generally speaking, penguins don't do very much flying. And then from there, if we wanted to think about the disjunction as well, it would follow into a very similar pattern, where we have P is true, Q is true, that gets P or Q to be true. If P is false and Q is true, we only need one there because we can say one or the other. That would have a true disjunction. Similarly, if P is false and Q is true, we get a true disjunction. The only case where we have that it is false is if both are false. P and Q are both false, then P or Q must also be false. Where we are using a thing called an inclusive or here. There's an idea of an exclusive or you can also get into, but we're not going to worry about that for now. So to think in terms of penguins again, you could say that the statement penguins can fly or penguins can swim is true, even though really the only case that matters there is the second one. But yeah, either or, one of them is true, that's good enough for the truth of that sort of statement. So from here, now we have a little bit of an idea of how these things work and what it is that we're trying to do with a truth table, which is just represent our options, not necessarily worry about whether something actually is or isn't true just yet. Let's look a little bit more about how we can make a truth table to develop our choices, as it were.